Question 27, Part B. Note that the wording of the question has been modified from the original text. Two unbiased dice are thrown. The dice each have 6 faces. The faces are numbered 1, 2, 3, 4, 5, and 6. Part 1. What is the probability that neither shows a 6? The outcomes of each die are independent of each other. In other words, when the second die is thrown, what it shows does not depend on what the first die has shown. Let the outcome of each die be D1 and D2. Hence, the probability that D1 is not 6 and D2 is not 6 is equal to the probability that D1 is not 6, which is 5 over 6, that is 1, 2, 3, 4, or 5 out of the 6 possible outcomes, multiplied by 5 over 6, which equals 25 over 36. Therefore, the probability that neither die shows a 6 is 25 over 36. Part 2. Dale plays a game with these dice. There is no entry fee. When the dice are thrown, Dale wins $20 if both dice show a 6. He wins $2 if there is only one 6. He loses $2 if neither shows a 6. How much money would Dale be expected to win or lose on average? The game is based on 3 possible outcomes. Either both dice shows a 6, one of the dice shows a 6, or none of the dice show a 6. Now, the probability that both dice show a 6 is equal to 1 over 6 times 1 over 6, which equals 1 over 36. Now, using the result from part 1, which is this result here, and applying the law of complements, the probability that only one of the dice shows a 6 is equal to 1 minus 25 over 36 plus 1 over 36 in brackets, and that equals 5 over 18. We now have the probabilities of all 3 possible outcomes. So the situation may be modelled using a discrete probability distribution, as shown in this table. Now, the top row shows the amount of money Dale could either win or lose. Notice this value here, which is negative $2. So Dale will lose $2 if neither dice shows a 6, and there's a 25 over 36 chance of that happening. Dale will win $2 if one of the dice shows a 6, and there's a 5 over 18 chance of that happening. And Dale will win $20 if both dice show a 6, and there's a 1 over 36 chance of that happening. So the average win or loss is found by finding the expected value of the random variable x. So the expected value of x is equal to negative 2 times 25 over 36 plus 2 times 5 over 18 plus 20 times 1 over 36, which equals negative 0.2777 and so on, which rounds to negative 0.28, correct to 2 decimal places. Therefore, Dale is expected to lose 28 cents on average every time he plays.